Hi, in this video we are going to talk about recursion, a very popular topic in computer science. This is used in many problem solvings. You have dynamic programming. The first step in dynamic programming solutions is to come up with a recursive solution. We have to come up with a recursive solution, then we write the dynamic programming code. Backtracking algorithms, they are recursion based. So if you have a problem which is solved using backtracking, you first write a recursive code, then you cut down the recursion by writing some cases where you can't lead to a solution. Divide and conquer, merge sort, quick sort, these are all recursive algorithms by nature. Tree traversals, most of the tree problems, they have solutions based on in-order traversal, pre-order traversal, post-order traversal, which are inherently recursive. So there are many applications of recursion. Let's understand it from the basics. The idea of recursion is to take a problem, break it into smaller problems. For example, if input is n, you can break it into n minus 1 or n by a or n minus 2 or n minus any value. You keep breaking the problem into smaller problems. So there comes a case where you cannot break it further. For example, factorial of a number. So let me first define what is factorial. Factorial of 4 is 24. How do we get it? 4 into 3 into 2 into 1. So if I have to compute factorial of 4, I know that if I have factorial of 3, I can multiply it with 4 and I can get the factorial of 4, right? So if I have solution for n minus 1, I can compute the overall solution. So if you have a problem and if you can compute the overall solution by using solutions of smaller problems, you can write a recursive code, right? So what we do is we keep breaking into smaller problems, but there comes a case where you cannot break it further. For example, for 4 when I called, I use the solution for 3. When at 3 I called, I use the solution for factorial of 2. Then I use the solution of 1. When I come to 1, I use the solution of, I call the solution for 0. So when I come to 0, I cannot break it further because after 0 you have minus 1, right? And minus 1's factorial is not defined. So when 0 comes, you explicitly handle it and you return 1 in that case. So general idea of recursion, you keep breaking the problem into smaller problems, you stop when you cannot break it further, and these particular cases are called base cases. Let us take a look at this factorial example again. Here we have written a recursive code. One important thing to note in recursive code is the meaning of recursive calls for smaller problems should be same. So if this factorial computes factorial of n, then it should be computing factorial of n minus 1, right? Its return value meaning should also be same. It should also be returning the factorial. Number of parameters, parameter types, they should all be same. So it should just be smaller problem with the similar parameters and similar return values, right? It should not be a different function call. Meaning of things should also be same. So here we called for factorial n minus 1, we used its value, multiply its value with n, and then that's how we compute the factorial n. And then we reach a base case. If we keep reducing, there comes a case where we cannot break it further. So in that particular case, we return 1. Let's understand working of this code. Say we call for factorial 4. Factorial 4 will go inside the if. It sees that n is not 0, comes to the else part. It makes a call for factorial of 3. So we make a call for factorial 3, factorial 2, factorial 1, factorial 0. So when we come for 0, it goes into the if part and returns 1 to its parent. So it returns 1 to its parent, right? Now the control comes back to the parent call, which was for factorial 1, because all the parent calls, they hold at that point when they called their children, right? So factorial 4 is still, in process, not done yet. Factorial 3 is also in process, not done yet. Factorial, same is the case with factorial 2, factorial 1. Say all are waiting in the function call stack. Now this stack starts unwinding, right? So when factorial 0 is called, it goes into the base case, returns 1. Factorial 1 gets its control back and continues from the same line where it called factorial 0. So it substitutes the value 1 here, which was returned by factorial 0 call, multiplies 1 with n, which is 1 here for factorial 1, and it returns 1 into 1 to its parent. So it returns 1 to its parent. Now control comes to factorial 2 because the child call is over. Factorial 2 called for factorial 1 here, and this child call is over, and it returned 1. Now factorial 2, it uses this value 1, multiplies this value with 2 because we called it for 2, and returns 2 into 1 to its parent. It returns 2 to its parent. Now the control comes to factorial 3. It uses the value returned by factorial 2, which is 2, multiplies it with 3, gets 6, and returns to its parent. So 6 is returned here. Now control comes to factorial 4, and it stopped here, right? It called for factorial 3 and it stopped here. So it uses the return value of factorial 3, which is 6, multiplies it with 4, and returns 24 to its parent call. And its parent call must have been some driver code or some other code. So this is the parent call for factorial 4. So it returns 24 to its parent call, which is main function, and you get 24 on your screen. I have written C++ style syntax here. In Java, we'll have public static void main in a class, and we'll have system.out.println here. So that's how this recursion works. So parent, it calls its child, it calls its child, it calls its child. It keeps happening until you end up in a base case. And once you reach a base case, this function called stack starts unwinding. And every function starts returning to its parent, and parent function calls, they start resuming their execution from the point where they left, right? So fact1 started from this point, use the value of fact0. Fact2 again resumed from this point when fact1 was over. So everybody starts resuming from the same point, start returning to the parents. Ultimately, the main function returns to the caller of it, main function, and you get the factorial value of 4. Let us take a look at this example. Let us try to guess the output of this program. This is a very nice program to understand recursion because you do something before recursion, you print something after recursion. So this is C++ program. In Java, I can replace cout with system.out.println here also. I need to guess the output. I'm calling this function for value 3. You may pause the video now. Try using recursive calls yourself. Try to print the output using pen and paper. I'll tell you the output after the pause. So the output for this program is 3, 2, 1, 1, 2, 3. Let's see how do we get this output. We call for fun3. Fun3, what it does is, it first goes inside it. It checks for n is smaller than 1. It's not smaller than 1, so it goes here. It prints 3. Right? So I'm writing print 3, which means 3 is printed on the screen. Right? It prints 3 on the screen. After that, it makes a recursive call to fun2. Right? The control comes here. When the control comes here, fun3's execution is paused, and fun2 starts its execution from the point here, right? From the beginning point. Since 2 is small, not smaller than 1, it goes here. It prints 2. After it prints 2, it also comes here and makes a recursive call for fun1. Note that fun2's execution is paused here, right? Fun1 again starts from its execution from this point, and it goes into the else part, right? And it prints 1. Then it goes here, makes a recursive call for fun0. Fun0, when called, it goes inside the if condition because n is smaller than 1 now. So for 0, you return immediately. So fun0 doesn't do anything. It is called and it is returned immediately, right? Doesn't do anything. After fun0 is over, these functions who were waiting, they start executing one by one. Your stack starts unwinding. Fun0 returns control back to fun1. Fun1 which was paused last, right? So fun1 starts its execution from this point, right? Fun0 call is over. And now it prints 1. So fun1 prints 1, right? So you got 3 on the screen first, then you got 2 on the screen, then you got 1 on the screen, and next one comes after it. So fun1, after printing 1, finishes here because there is nothing more to execute, and control comes back to fun2. So fun2, which was waiting here for fun1 to finish, prints 2 now. So fun2 gets its control back and prints 2. So fun2 has nothing more to do now. It returns and sends control back to fun3. Fun3, which was waiting here at this point, now prints 3. So you got the output 3, 2, 1, 1, 2, 3. So with this example, we saw what happens in recursion, what happens before the recursive call is made, and what happens after the recursive call is over. So when you reach the base case, a stack starts unwinding and you start returning controls back to the callers one by one.